This is Chapter 6, page 7 of the notes. We're going to be continuing on with naming ternary ionic compounds. And what we have right here is we have CuCN. We're going to name Cu, that is copper. Since we don't know its charge, because it's not an alkali or alkaline metal, we're going to put the parentheses. And Cn is cyanide. Our charge on cyanide is a -1. We only have one. We have one copper, so our charge on copper has to be +1, which means you're going to put a Roman numeral 1 in there. So let's try the next one. We have Fe2 So4 3. Fe is iron. We don't know the charge on iron, so get our parentheses ready to fill in. So4 3 is sulfate. We know our charge on sulfate is -2. So we have 3 of these. So we've got a -2, a -2, and a -2, because we have 3 of these sulfates. So our iron has to cancel out to a +6 up here. But notice we have 2 irons. So 2 Fe, whatever it is, we have to figure out what X is, cancels -6, which means X has to be a +3. So it's a Roman numeral 3 up here. So iron 3 sulfate. Okay, we actually finished the toughest part of the naming. We're now actually rolling back to something that's easier. We're going to learn how to name binary molecular compounds. Now, these are composed of 2 nonmetals. So you can think of this as an upstairs marriage, above the staircase. So an upstairs marriage. These are molecules. And because there are molecules, there are no ions or charges involved, which makes things a whole lot easier. What you do need to do is memorize some prefixes that show the number of each type of atom present. So 1 is mono, like a monologue. 2 is di. 3 is tri. 4 is tetra, like a tetrapod. That would mean 4 legs. After this, the prefixes are based on geometrical shapes. So if you know your geometrical shapes, you know the prefixes. 5 sides would be a pentagon, so it's penta. 6 is a hexagon, so it would be hexa. 7 is hepta. 8 is octa, like a stop sign, so octa. 9 is nona. And 10 is deca, and that's as far up as I'll make you memorize. Okay, so mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. We're going to scroll down the page now. All right, exceptions. You are not going to use mono when you're referring to the first element. So do not use mono with the first element. It's implied if you don't put it in. And then the other thing is that you drop prefixes ending with an A or an O with oxygen compounds. Now this is picky. If you forget to do this, I won't mark you wrong, but ideally you should drop prefixes ending with A or O with oxygen compounds. So let's go from names to compound. Phosphorus trichloride would be PCl3, tri being 3. Nitrogen dioxide would be NO2. Dinitrogen pentoxide would be N2O5. And carbon monoxide would be CO. Okay, let's try going the other way. We're going to go from formula to name. We have one carbon, but we don't use mono in front of the first element, so it's just carbon. We have 4 fluorines, so we use the prefix tetra, and it's fluoride. So you are ending with the IDE with the second element. Next one, we've got 2, so it's di, and then phosphorus. We have 5 oxygens, that's penta, but because it's oxide, we drop the A and it's pentoxide. So we didn't say pentaoxide, we said pentoxide. SiO2 would be silicon. We have 2 oxygens, so we use the prefix dioxide. And then our last one, we have arsenic. The prefix is tri, and then it's chloride.